Jan Ozer here from NAB. I'm with Dan Pisarski, who is the VP of Engineering here at LiveU. We're going to talk about two trends in contribution delivery, 5G and HEVC.
Yes.
Thanks for joining us.
Thank you.
So you guys came out with some interesting HEVC related statistics this year. Tell us about those.
Yes. Since LiveU's launched our HEVC-based products, we've seen a huge uptake of HEVC use. I mean, for contribution, it only makes sense, right? You're getting, even if you're still doing HD, not UHD, you're getting a much better looking stream at half the bits. And so in a cellular bonded environment where every bit counts, and if your bandwidth takes a little dive, you still want the greatest quality you can get, that's a huge boost. Plus, on this cellular bonding side, everybody's mindful of how much data they use. We all want to do more production, more video for the same price that we're doing, and so being able to use half the bits to get that has been a huge boost for broadcasters. So we saw just a gigantic use of HEVC in our first year of really having HEVC on the market.
Okay, and you say half the bits. I mean, is that what you've been experiencing? Is it really cutting the data rate in half?
We've experienced with the hardware that we deployed, it's really about half, right?
Okay.
You get the same quality 720p or 1080i or 1080p stream for half the bitrate that you were using before.
So how's that work? Because when I tried the product, I had to, my ultimate destination was YouTube Live, and I had to route the signal through your cloud system to kind of convert so if you're sending to a system that doesn't support HEVC, how does that work?
Yeah, so we're a first mile solution, right? We use HEVC from the actual portable device up to the cloud, and then we will convert it to H.264, because you're right, most of the online platforms right now are not taking HEVC in. And we've spoken to a lot of the online platforms about their plans, and it seems like for a lot of them, HEVC ingress isn't on the roadmap, right? For various reasons, their relationship with the HEVC licensing bodies and things like that. So it's probably going to involve that transcode in the cloud back to H.264 for some time. But all the benefits that you're looking for in the first mile, less bits used on your data plans, better looking video in those tough conditions of actually out in the field and broadcasting over cellular are all solved. And then that H.264 step is what we call cloud to cloud. So it's going from wherever you're hosting either our decode server or where we're hosting our cloud software into your ingress point. That's usually going directly from some giant cloud data center to another cloud data center, so the bandwidth is rarely a challenge there, right? You've got plenty of bandwidth there.
Okay, there's one more conversion, I guess, from HEVC to H.264 and then to the service.
Right.
Are you seeing any degradation in quality with that additional transcode?
No, you can tune the quality there. So you've got a great looking image coming from the HEVC decode, and then you're feeding that into a high quality H.264 software encoder, and you were able to pick a very high bit rate there because, again, you're going cloud to cloud, and it's not something that's costing you on your cellular data plan, for instance. So if you're doing 4 megs of HEVC out of the field, you're doing 8 megs of H.264 into YouTube or higher, and you still get a great looking image.
Okay, what's the cloud cost? Are you familiar with the pricing structure? I mean, how much does that add versus point-to-point H.264?
So, the way LiveU does it, we really have kind of dedicated cloud resources, and we have a pricing on that, but it's not a pricing that's isolated to just the HEVC to H.264 transcode. You were paying that cloud cost with LiveU anyway to get our receive bonding, to get all the functionality that cloud server provides to you, and that price hasn't changed to add that transcode. We already had enough CPU dedicated to that instance to do that transcode for you. I know some other companies have kind of broken it off into a freestanding service and come up with pricing for that. So for the average user just across the industry, I'm sure there's a cost factor there, but for us, you were already paying us for that CPU power, and that CPU power was already enough to get done what we needed to get done.
And that's a great point. Even if you're doing multi-modem bonding, you need to receive in your cloud anyway.
Right.
Because
right.
Facebook isn't going to know what the signal is coming in from one of those if you've got 4 modems doing it. So it's really, it shouldn't, how much latency does it introduce?
It's right around 500 milliseconds of latency for that transcode in the cloud.
Okay. Well, latency is or is not a big deal for most of your customers, and if it is a big deal, what are you guys doing in that respect?
So it is a big deal for a lot of our customers, and so what we've done in our bonding algorithm is drive down the latency in each new version we put out. So probably just about a year ago, probably at the show last year, we were at 1.2 seconds latency point to point. So really glass to glass if you were going to baseband, but from the unit in the field to that transcode step when we're talking about the streaming to online. So 1.2 a year ago, then the next version came out, drove it down to 1, and now we have a version out that does 800 milliseconds. That's all over modems. If you happen to be on LAN or fiber or something like that, you can go down to 600 milliseconds on our units.
Okay, and another completely different topic relates to 5G, and I've just heard some pretty outrageous things about it in terms of health scares. And so when is 5G going to be a thing? When are you guys going to have a product for it? And what's the reality as it relates to that health-related concerns we've been hearing?
So, 5G, to reach the numbers that really kind of get talked about a lot and advertised about 5G, gigabit through the air or even higher, uses what's called millimeter wave, which are frequencies at 30 gigahertz and above. That's a high frequency transmission compared to 5 gigahertz at the highest that you use right now for either LTE or Wi-Fi. But it's all the same RF energy in the air, and there's been a lot of studies done about RF energy in the air that show that you really have to be very, very close to the transmitting unit, and it has to be at very high power to actually impact the cells of the body. So when you're actually just talking about a unit that's in a backpack or sitting on a table or even a phone held to the side of your head, it's not close enough, right? Only the use case of literally holding it right to the side of your head for an extreme long amount of time is really close enough to have that risk. The strength of the signal from a point of view of impact to cells of the body falls off so rapidly, even just an inch away, that there's almost no impact. That doesn't change with millimeter wave just because of the high frequency, right? All that properties of RF frequencies are still true. So millimeter wave is exciting. It's got some challenges from a technical standpoint of it bounces off of all solid objects. It can even bounce off of water in the air, so it doesn't have as long distances that can go with some of the sub 6 gigahertz frequencies. But that's all the challenge that the carriers are taking on to make 5G work, and they've got solutions for it, like directional antennas and beamforming antennas and things like that to have that signal work. And we've seen tests where they've gotten great mobile moving millimeter wave speeds, a gig through the air in tests in the field. So it's very exciting stuff for us. We know it's going to lead to units that have higher bandwidth, lower latency, better looking pictures, more video transmissions over a single unit, more video transmissions over a single modem, all sent through it. We're really excited to kind of start launching features like that. Realistically, people get a little gung-ho on the kind of launch dates, we think. So right now you're starting to hear about, we've got 5G deployed here, or now it's deployed in these cities, but the deployments are very, very limited. And we think that really it'll take more towards the middle of 2020 before you see real true citywide deployments that are usable by many devices, right?
So when do you get out in front of that? When would you expect to see your first 5G product out?
Definitely before then. I mean, we're in the lab right now with the carriers, trying it with the larger antennas and larger modems that are available right now, so that we can see how the whole system operates. We're talking to the modem vendors that make the smaller units and smaller antennas and figuring out how they're going to fit in the units. So I think you'll see a LiveU unit that's got true millimeter wave 5G integrated in it. Really, maybe early 2020, but just my guess.
And that's not really your thing. Basically, you accept, you push data out the serial port, and you've got to decode it. And
well, we get involved because a lot of our products use internal antennas. We work with antenna designers. It makes us a little unique in the market compared to some other products. And so we get involved at that level. Right now it requires brand new antennas that work on different frequencies, parts like that. You're right, the actual modem itself comes from another manufacturer, and we talk to it through a serial API, and it broadcasts data. But we definitely get involved in, all right, how much power does that have to draw? How does it need more cooling than the other one? It's the same physical size as the other modem. Now it's got to plug into antenna. How big is that antenna? And where does the antenna have to sit in the unit? So there's a lot of engineering there to do that we're already started on.
Is it going to show up in a unit that size, or is it going to be a lot bigger, or what's your sense of that?
So we're kind of working with millimeter wave antennas right now to get a sense of that, but we've seen some examples of millimeter wave antennas that would fit in a unit like this. So we've got high hopes that it's not going to make units get bigger all of a sudden to support millimeter wave.
Okay. Listen, I appreciate you taking the time, and have a great show.
Thank you very much.